Hey, it's Lucky. Kenny is one of the best free asset suppliers on the market right now. I've used and linked his assets in most tutorials I made on this channel. And recently he has launched 3 open source starter kits for Godot. I shot him an email asking if I could break the projects down for you guys, and he gave me permission. So today we're going to be taking a look at the 3 most polished and well-made demos I've ever seen for Godot. Let's get into it. So first let me show you how you can get these projects. You can either go to Kenny's GitHub, be the first link in the description, and you can find all the kits here. In the intro I said I asked for permission to make this video, but all the projects are under an MIT license, so you can do with it whatever you want. But I just asked for permission because I wasn't sure if he was going to make any content on breaking these projects down. But yeah, they're all MIT licenses, so yeah, you can either download them from his GitHub by just clicking any of the projects, going to code and then download zip, or an easier way is just to go into your Godot launcher, go to asset library and look for Kenny, and you can just download them here straight in Godot. Now, even when adding these projects into your file browser, you can already see that nice Kenny polish. I didn't even know you could add labels to a project. But yeah, you can see he added this little starter kit label to all his starter kits, a little icon, and check this out. Even a splash screen on the editor. Oh, beautiful, beautiful. Alright, so the first one I wanted to take a look at is the platformer demo. Let's run through it real quick. There are a couple things I want to take note of here. First off, sound effects. I really like that running sound effect, the little splashy sound on the feet. The particle trail on the character. Really premium, love it. And you can also see some morphing of the character when jumping. You see a little stretching of the body. We'll get into that in a second. Another thing I want to take note of is the character has this straight down shadow. It's used in a lot of 3D platformers to see where you're actually landing. You can see the real shadows here on the left, but there's this second shadow right there. We'll also take a look at how he does this. Another thing I want to take note of is you can see the clouds. They're disappearing as they get into the camera's view. Also have a look at this feature. And you can see when we rotate the camera and then walk again, the controls are mapped to the camera view. So when the camera is rotated, the controls are mapped accordingly. It's also a very nice feature, and we'll also take a look at that. So yeah, overall, really good platformer demo. The controls feel super snappy. Sound design, and of course the visual design are as we expect from Kenny. Beautiful, stylized. So let's have a look at the project. This is the only real scene in the project, the main scene. And we have a couple sub-scenes for the player and the platforms. So before jumping into any assets or code, I would like to take a look at his file organization. You can see he has all his assets laid out in different folders in his main folder. I usually add an assets folder for my fonts, meshes, models, materials, and then have a separate folder for scenes and scripts. So my main folder will just be assets, scenes, and scripts. This is of course also a great way to organize your files. It's very structured and nice to look at. So the first thing I would like to take a look at is the player. This little guy right here, and how he managed to do that warping effect when animating. So we'll go down into this player scene by clicking the little clipper icon. So let's run down this hierarchy. So we have the player node, which is a character body 3D, which is expected for a physics character. And then we have the collision shape, which is called collider here. It's using a basic capsule shape. Nothing too surprising here yet. Then the character is an imported 3D model with an animation player. This is how models come when they're imported as a GLB or GLTF. They come with the meshes and the animation player all in one. And we can see in the animation player, if we click on it, we have our idle animation, which is just him bobbing up and down. We have our walking animation. This is just a basic T-pose or the reset pose. And then we have the jump, which is just him floating in the air. And you can see that actually the jumping animation we saw in-game was done purely in code. So we'll have a look at that. Then for that shadow that I talked about, the one that was straight below the character, he's using a decal. Decals are usually used for bullet holes or like sprays on walls in video games. If I just add a decal right into this scene, drag it onto this main platform, and then give the decal a texture. key icon, you can see it projects this image onto whatever geometry is below. So yeah, this is very useful for bullet holes, sprays in video games, just posters on walls, and also for these kinds of shadows. They're like these retro shadows, the straight down blobby shadows. So yeah, let's delete that, go back to the player. So then we get to the particle system. You can see as the particle he uses this mesh, which is actually an array mesh and not just a model. You can see in the hierarchy here in meshes, dust.res, it's an array mesh. It's just a little more optimized. And the most important part for making this effect work is having local coords turned off, meaning that the particles get spawned in the global coordinate system, meaning you get this trail effect. If you put it on local, the local coordinates of the system will be used, so they won't be trailing, they'll just stay static. Other than that, it's a very basic particle system, just a continuous particle trail. He tweaked the scale amounts a little bit and the scale curve to give this nice poofy effect. And then lastly, he has an audio stream player in the player scene, and it's just that satisfying that sound. It's really nice, reminds me of some Minecraft sound effects or something. So yeah, I tweaked the volume and the pitch scale a little bit. That just depends on your sound effect. So let's have a look at the script. I'm not going to go over every script in great detail in this video, because I want to keep this video at a reasonable length. But I just want to point some things out about the script. And I would highly encourage you to go into the projects yourself and read through this code. It's very clean, well-written code with nice comments, so yeah, it should be very readable for anybody. One thing I want to take note of is these export subgroups. They're just another nice layer of polish. If you go to your player node and you see these exported vars, they all come in their own little subgroup, making it very readable and usable. So yeah, this is just a very basic physics movement script. You see there's one signal connected for collected coins. This means when the player collects a coin, it sends a signal to the HUD, updating the coin count in the corner. Right here in handle controls, you can see the input is mapped to the camera view's rotation, meaning the controls will rotate with the camera. And here you can see the audio for jump playing, and this is actually interesting because it's using a custom audio script. Let me quickly open that up. So yeah, it's an adapted script from KitScan Code. And it's basically an audio player that creates and destroys audio stream players on command. This is very handy if you've used a lot of audio players in a project. You know they can get very messy. You can have a lot of audio players for all these different sound effects. Like every coin having its own audio player, for example. This script takes care of that by creating audio players when they're needed, when there's audio queued, and removing them when they're no longer needed. So yeah, really clean solution to having a lot of audio playing in your game. Definitely also check this one out. The last thing I wanted to take a look at in this project is those little disappearing clouds. Not because they're very special, but just because they surprised me that there's such an elegant solution to having these proximity fades. It's basically all just in the material. So if we go to the cloud, go to its scene, and then you can see the material is overwritten here. And there's just this feature, distance fade, in every material. I didn't know this. This is new information to me. But yeah, it's super clean. Just a little proximity fade. You can just enable it in any material you have. Oh, and I totally forgot to mention how he did this jumping effect. The little morph. Super easy. In his player controller at every frame, so in this physics process, he is lerping his model scale to 1.1, so just the default scale, with a speed of 10. And then when he jumps, he quickly warps this player to be like a little long and thin, and then the script will automatically take care of morphing it back to the regular size. So yeah, you can just morph your player for certain animations and then have this line of code reset the scale automatically. Yeah, it's a really, really nice effect. I really like it. You can see a little squash. And that's all it is, just 2 lines of code. Alright, now really moving on to the next one. So I just edited that first part and it was already 10 minutes. So I'm gonna pick up the speed a little bit, just because I don't want to make this video half an hour long. Let's move on to the city builder kit. I think this project is a nice example of data structure. Let me explain. So the main scene is basically empty. There's only the selector and a grid map. That me run it first. And you can see you just spawn in an empty world with this little selector that is moving along the grid map. You can place tiles, select new tiles, and build out little cities. And you can rotate the view with the middle mouse button. And you can save by going F1 and load by going F2. And this is actually saving the map to a file in your file system. So let's also have a look at that. So the main script here is the builder script. In here you have an array of structures and you have a data map. And then he's getting a bunch of nodes for the little selector, the preview model, the camera, the actual grid map, and the cache display. And he has a little collision plane for ray tracing the mouse. So when I say this is a nice example of data structure, if you actually go into the data structure file, this is a it's a little bit confusing that I'm saying data structure and he's using structures as in buildings, but I'm meaning structure as in a structured data setting. But yeah, you can see he creates this resource for all his buildings, which is hold in position, which is a vector to I because they're on a grid, so there's no float point. And then an orientation, which is the rotation, so also an integer because it's one of 4 rotations and not at a float point. And then an ID for the actual structure model. Then these all get added to an array in the data map. You can see here's a giant array of all these little structures, and he's holding a variable for how many cash you have to spend on buildings. So yeah, he's building this one resource, which is then containing in the second resource. And you can see in the code on the ready function, he's instantiating this data map. Then creating a mesh library. Mesh libraries are basically used for grid maps. You can almost see it as a tile set for a 2D tile map, but instead you're using meshes on a 3D grid map. And he's looping through all the structures and adding those to his mesh library, and then setting that mesh library to the grid map. And then in the process function, there's a bunch of logic for finding the mouse position in the world. So basically he's casting an array from the camera to this invisible plane that's at the world origin to find the actual mouse position in the world. Then converting that to a grid position by rounding out these world positions. And then lerping that selector position to that grid position. This gives that smooth, you can see the selector is like snapping with this little animation. That's what that lerp function is doing. And then he's checking for action build and action demolish. So you can see in action build if the mouse button is pressed or the build command. He's setting that cell item and he's checking if the tile you're building on is not already built with the same tile. And if it's not, then he's taking out the cache, meaning that if you're building a new tile, you're going to pay. And if it's the same tile below, he's not going to retract any money from the cache variable. Demolish is super simple. He's just going to get the cell item at the position and remove it. So here there are 2 more functions for the selector. Here is selecting next and previous structure, and here he's updating the actual model in the selector. Then this is just a super easy cache update. He's just updating the text on the little cache label right there. And then here's some more interesting code for saving and loading. You can see he converts all the cells in the grid map to his data structure. And then he adds in all those cells into the data structure, and then he saves those using the resource saver and doing the reverse here in load. So yeah, once again, very easy and readable code. Definitely look into this one if you're looking for creating your own resources and data structures. And the last script is just a view, which just handles moving the camera and rotating the camera with the middle mouse button. So yeah, great example of using resources and data structure and saving that data. Definitely also have a look at this one, and let's move on to the last one, the FPS demo. So the last one, the FPS Starter Kit. This one had me a little confused at first. Let me show you why. When you play this with keyboard and mouse, you can see the, well, I'm not sure you can see it, but you can feel that the rotation is smoothed. So when you look with your mouse up and down, left and right, there's a certain smoothing to it. It isn't instant. It's like one-to-one to your mouse. It's a little delay. And at first I was wondering if this was a design choice, because it does look nicer in a recording, but it doesn't play very nice. But then I realized that this project was built for keyboard and mouse and controller. So this actually plays very nicely on a controller. But I would, if it was my project, I would snap the view just one-to-one to the mouse to avoid this little smoothing. But yeah, it's a great example for setting up a controller for keyboard and mouse and controller at the same time. So let's have a look at the code. I did notice some script files were in the objects folder here. I'm not sure why that is. I don't see any good reason for having your scripts within an objects folder instead of just its own scripts folder. But maybe I'm missing something. But yeah, that's just something I noticed. Taking a look at the player script. It's a very well laid out first-person controller. I made a lot of first-person controllers, so when looking at this, there's a lot of things I recognize. In the ready function, he's capturing the mouse and instantiating his first weapon. Then in his physics function, he's handling controls and gravity. And then he's applying those input vectors to the player. And right here is the rotation where you can see the camera is being lerped. So you can see the mouse input X is being lerped to the actual rotation, giving that smoothing to the mouse look, which I was talking about before. But this is, I believe this is done to compensate for joysticks. Because if you have a joystick one-to-one to your view, it's going to be very snappy and hard to control. Having a little bit of smoothing in there makes it feel a lot better for controllers. But in my opinion, not that great for mouse inputs. So yeah, it's a personal choice. You might find that this feels more premium in your project. Definitely download this project and give it a try to see what I'm talking about. So after this, it's just a lot of first-person controller code. So here's getting that input, and he's getting that mouse input. Here he's handling the captured state of the mouse, so whether the mouse is captured within the window or free. So yeah, after that rotation logic, there's some logic for movement sound, detecting if the player is on the floor and if he's walking at a certain speed, then playing that footstep sound effect. And here you can see landing logic, checking if he just landed on the floor with still a gravity applied, and he was previously not on the floor, he just landed. And he uses that same audio script that we showed in the first demo to play a landing sound. And here he's updating the previous float for this little piece of logic. And there's a respawning logic, meaning if you fall off the platforms, he just reloads the whole scene. Here's the input function that gets the mouse movement and then sets the target rotation. And here in handle controls, you can see the mouse capture and release logic. And here's movement logic, basically WASD for moving around, setting that movement vector with those axes. And then in rotation, he's setting those rotation inputs again. And that's just because this is for the controller inputs. So here's getting the axis of the joysticks, and here he's getting the mouse movement. Which looks like this logic could be overlapping, but yeah, nobody's going to be using a controller and a mouse and keyboard at the same time. So that's why they can both affect this rotation input without causing any conflicts. Then he's checking for action shoot. We'll go into that function later, and here's just basic jumping logic using that audio player again, that audio script, to play different jump sounds. Then we got a function for handling gravity, it just adds gravity to the player. The action jump function we talked about earlier, just slaps on a jump strength on the gravity, it's totally fine. Then there's a bunch of weapon logic in here. He actually made these weapons as a resource. So you can see all the weapon settings are in here as exported ranges. So in theory, you could really easily add your own weapons to this, and I would highly encourage you to try and tweak these settings and build your own little weapon. In the demo, I'm not sure I actually showed this, but in the demo there's two weapons. You have this really beefy sounding machine gun. And this shotgun. But yeah, both these weapons are built using this resource. So definitely play around with it, try and build your own weapon, could be a lot of fun. So yeah, the following logic is a bunch of knockback logic, like punching the camera back a bit and the weapon back, and actually punching the whole player back. It's got like this physics knockback, it's kind of fun. And here's a bunch of logic for spawning the muzzle flash and setting its position. You can see that muzzle position, which is set in this resource. You can tweak all those settings Then shooting the weapon based on shot count. This is basically for shooting multiple bullets, so the shotgun probably shoots 3. Let's see if I can find that shotgun resource. Yeah, shotgun 3. So the shotgun fires 3 bullets and that machine gun fires 1. And that's basically what this logic is for. Shooting all those raycasts and checking if anything that was damaged has a method damaged to damage the enemies. And loading a little impact scene for a little impact effect. And then after that we get a bunch of logic for changing the weapons. So you can see he uses a tween, an ease in and out for moving the weapon up and down. Let me show you. You see that little switch? It's just all in code with a little tween. Here's the actual changing of the weapon. He removes the current weapon, places in the new weapon, and sets that weapon position, and then adds it to a second layer. He is actually using 2 cameras, one for rendering the world and one for rendering the view model. I also covered this in my first-person animation tutorial. This is how you keep your weapon from clipping through the world. You can see he used that sub-view port container and a second camera for just the weapon and 1 camera for just the world to not have the model clip through the world. And last, there's a function for taking damage from the enemy. You can see in the enemy script, he's always going to look at the player, and then on a certain timer, he's going to shoot a bullet at the player, giving a little muzzle flash and damaging the player by 5 damage. So yeah, that's the last demo, the little first-person shooter demo. Also really like this one. Great example of using both keyboard and controller support in a project. And I mean, this sound effect is just so satisfying. So yeah, I hope you guys have a look at these projects. Definitely break them down yourself. There's a lot of stuff in there I didn't cover yet, and there's so much fun to just dive into and pick apart, and everything is very readable. So if you want to see how a feature is done, you can definitely find it in the project and learn a lot. So yeah, download these projects. They're amazing. They're well polished. I love them. I learned a lot from them. I hope you do too. And until next time, see ya.